lattice contribution. First, let's see what we will study. First, it's the Dulong Petit law. Then we'll see Einstein's theory, and then finally the Debye theory. First, the Dulong and Petit law. If there are n atoms in a lattice, he assumed all of them to be classical harmonic oscillator. Now in 3D, if there are n atoms, then in 3D you can assume it to be 3n harmonic oscillators, right? So the Hamiltonian will be I equals to 1 to 3n p square by 2m plus half m omega square xi square, right? So from equipartition theorem, since for every quadratic term there will be, and the contribution to specific heat is the contribution to energy is half kBT, right? Half kBT. Now there are how many quadratic terms are there? So 2 pi square and xi square, so 2, and there are 3n classical harmonic oscillators, so into 3n kBT, half kBT. So this will get cancelled, and sorry, I made a mistake. This is, I wrote half kBT twice, so let's so U is 3n kBT, right? So CV will be, so CV is du by dt. So here d by dt 3n kBT, so 3n kB, which is 3R. So this is the specific heat according to Dulong's and Petit's law, which is a constant. If we draw a graph between CV and T, it's like this, or 3n kB. Einstein, and gives Einstein's theory of specific heat. Now a brief summary, which is that experimentally the specific heat graph for specific heat versus temperature, we get this, something like this. This is 3R, and at low temperatures the specific heat is proportional to T cube, and after at high temperature the specific heat is approximately 3R. Okay, so the Dulong's Petit law, which said that CV is constant at 3R and doesn't depend on temperature, is wrong. It's only true at very high temperatures. So Einstein said, that instead of assuming simple classical harmonic oscillators, he assumed quantum harmonic oscillators with with 3n degrees of freedom. If there are n atoms or n lattice points, then 3n degrees of freedom. Why? Because in three-dimensional, obviously, because an atom can vibrate in three independent directions, and for each direction it can be considered as considered as a different independent harmonic oscillator. So 3n degrees of freedom, so there will be 3n oscillators, n atoms and 3n oscillators, right? So let's write the partition function. Partition function will be n equals to 0 to infinity e to the power beta en. And for classical harmonic oscillators, its energy runs from energy is n plus half h cut omega, where omega is 2 pi mu. Omega is the angular frequency, and the energy levels runs from 0 to infinity. So beta by 2 h cut omega, n equals to 0 to infinity e to the power n beta h cut omega, where n so this is a infinite GP series with the first term is 1. So the formula we can say this part is 1 by e to the power minus n beta h cut omega. Now the average energy is, we know, minus del beta of ln z, minus del beta of ln z. So but ln z is minus half beta h cut omega from this one. This is z, so ln z is this, minus ln 1 minus e to the power minus beta h cut omega. So from this equation again, average energy for each oscillator is half beta h cut omega plus ln 1 minus the h cut omega, half h cut omega plus e to the power minus beta h cut omega 1 minus e to the power minus beta h cut omega h cut omega. So this one is half h cut omega plus h cut omega by to the power beta h cut omega minus 1. So total energy of the whole system is 3n multiplied by the average energy, which is 3n half h cut omega plus h cut omega e to the power beta h cut omega minus 1. Now CV is du by dt. This part is independent of temperature, so the differentiation of it with respect to temperature goes to 0. So 3n into h cut omega to the power h cut omega by kt, h cut omega by kt minus 1 square to h cut omega by k 1 by t square. Now let h cut omega by k is te, kb obviously. Here every k means kb everywhere, the Boltzmann constant. So CV becomes 3nk te by t square e to the power te by t by t by t minus 1 whole square. Let me write it properly. Now at high temperature, we can say Te by T less than 1 because temperature is high. So e to the power T by T can be written as 1 plus T by T. This just the Taylor series expansion and ignoring the higher terms. So Cv can be written as 3nk Te by T square into 1 plus T by T divided by T by T square. So this is and again this term is very high, so this term is low, so this is again 3nk. This is 3R at high temperature. And now at case 2 is at low temperature. Now at low temperature T by T is high, right? Because this term is low, so overall this term is high. So we can say e to the Cv 3nk T by T square to the power T by T by T minus 1 square. So at the low temperature limit, this term is high, right? So the exponential term is high. The exponential term is high, so 3n, we can ignore this minus 1. T by T to the power T by T whole square. So nk T by T whole square e to the power minus T by T. This will get cancelled out and minus T by T. So at low temperature, we know this term is 1 by T square and this term is exponential 1 by T. So this obviously exponential term will dominate. So at low temperature Cv is minus T by T proportional to e to exponential of minus T by T, which gives us approximately the correct value. This is what we are supposed to get, but we get approximate the same value, but it's still imperfect. So to resolve this, Debye gave his own theory, Debye's theory. The problem with Einstein's theory was that he assumed all oscillators to be vibrating at the same frequency, which is a very simplistic assumption. Debye assumed that unlike Einstein, who assumed that all oscillators oscillate independent of each other, he assumed that the collective behavior of the lattice points or atoms. He assumed that the vibrations in solid or lattice travels in form of phonons, which are acoustic, similar to acoustic waves, and these are quantized. So now since it's a wave, we can say it to the e to the power I kx proportional to e to the power I kx, and subjecting to the periodicity of the waves, we can say e to the power I x kx plus L, where L is the dimension of the object. right? So k is plus 0 plus minus 2 pi by l plus minus 4 pi by l and so on. So this is k. So there's one mode of vibration in the region 2 pi by l, right? So we can write the density of modes in terms of k as 2 4 pi k square dk, which is this is the what is this this is the number of modes in dk interval. If it's a sphere of radius k, so this volume is 4 pi. This is a sphere, so this shaded volume is 4 pi k square dk. So 4 pi k square dk divided by the what is the minimum area in which there's only one mode. Well, 2 pi by l, this 2 pi by l in 3D, 2 pi by l cube, right? So this will become v q square v k square dk, where v is l cube. L is the dimension of the object, so the volume of the solid is L cube. It's a cubic solid, so V equals to L cube V k square divided by 2 pi square. Now since we know k is omega by nu, so we can write d nu is v by 2 pi square, the velocity. This is k equals to omega by v, sorry, not nu. This v is velocity of the sound waves, v cube into omega square d omega. So but now in 3D, if let's say if the sound waves are traveling in the x, this is in the x direction, then this is the longitudinal direction, and these two are the transverse directions. So the density of phonon states will be, the total density of phonon states would be v by 2 pi square omega square d omega, and the velocity in the longitudinal direction is vt, and in the transverse directions it's vt, and this is vl. Now since there are two directions in the transverse direction, there's two, right? So we will write 2 by vt cube plus 1 by vl cube. Okay, now let's assume the whole constant part to be a. So a this omega square d omega. Now I made a mistake again. Omega is 2 pi nu. So for finding the density of modes in terms of the frequency, it will be a nu square d nu. Just change omega with 2 pi nu. So a will get as 4 pi v 1 by c l cube plus 2 by c t cube. This one. Okay, so now what is density of modes mu? This is the distribution, let's say. Then d nu in then this area, which is d nu into d nu, this is the number of modes in d nu. So if we integrate it for the whole area, we will get 3n, because if n is the number of lattice points, right? Why 3? Because there are 3 independent uh, 3 n independent frequencies, three independent modes for each lattice point. And another thing to be noted is that since there are only 3n in 3n modes, so we cannot integrate it from 0 to infinity. There has to be an upper limit, which is the Debye frequency. Okay, so d nu is 3n, 0 to nu d. So this is we found out earlier that a nu square d nu is 3n. Okay, so nu d will come out to be 3n by a to the power 1 by 3. Okay, so now we need to calculate the energy so that we can calculate the specific heat later. So the energy is 0 to mu d, which is average energy multiplied by the density of states, right? This is mu d. We will follow the Bose-Einstein statistics, and we'll assume that each phonon has energy h nu. So the average energy will be h nu, which is average energy is h nu f nu, right? So and f nu is h nu by kt minus 1, and d nu is a nu square d nu, right? Now at case 1 is high temperature. At high temperature, h nu by kt is less than 1, which is h nu by kt is 1 plus h nu by kt, right? So u will become 0 to mu d h nu into kt by h nu into a nu square d nu, right? So kt into a to nu d cube by 3, but nu d cube is, we know, 9n by a, right? So again cv, u is proportional to t, so cv is again 3n kt, right? cv, sorry, is 3n k, just u is 3n kt. Okay, this is at high temperatures. Now at low temperatures, we know already 0 mu d is h nu e to the power h nu by kt minus 1 a nu square d nu, right? Let h nu by kt equals to x, so nu will be kt by h x. Now again we need to also change the limits. So at x equals to 0, at nu equals to 0, x is 0, and let nu equals to nu d, x is h nu d by kt, right? At low temperatures, x will move to infinity. So the integral becomes 0 to infinity kt x e to the power x minus 1 a h kt by h square x square kt by h dx, right? So u is a by h cube kt to the power 4 and 0 to infinity x cube by e to the power x minus 1 dx. Now the value of this is pi 4 to the power 4 by 15. Now so pi to the power 4 by 15 into a by h cube into kt to the power 4, right? So now if let's say theta d is h nu d by k, so u will become pi to the power 4 by 15 into 9n by mu d cube. A is, we know, 9n by mu d. New days 9n by a 1 to the power 3, so a is mu d cube by 9n, right? So we'll put that here into 1 by h cube into kt to the power 4. Okay, so it becomes 3 pi to the power 4 by 5 into nk into k by h mu d cube t to the power 4. So we can see that now again theta d is h nu d by k, right? So 3 pi by 4 into 5 into nk into t to the power 4 by theta d cube. So cv will become du by dt. This is 12 pi to the power 4 into 5, nk is r, so t cube by theta d cube. So at low temperatures, cv is proportional to t cube, which is experimentally true. So this is amongst all of the theories, Dulong's Petit laws, Einstein's theory, DY is the most appropriate, most accurate. In exam it gives, instead of 3D, if they give 2D, so what we'll do, we'll change this density of states. We know in 2D dk will be instead of considering a sphere here, we will consider a 2D circle, right? So this area will become 2 pi k dk divided by 2 pi by L square. So it's basically will become proportional to k, right? No, and not k square. So again here it will become proportional to just k and not proportional to omega, sorry, just omega, right? Instead of omega square it will become omega. Here also, here it will become just nu. Okay, and this will become just nu and not nu square. So this integral will also change. we'll come back to that later. At low temperatures, this integral, this will uh, become just nu. So in overall it will become this 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 it will become uh, nu, here nu and here another nu, so nu square. Here it was nu cube, right? Here it was, so here it will become uh, nu cube, here sorry, nu square, and after assuming h nu equals to kt, let's write it simply, it will become something like some constant into nu square d nu, right? So after assuming h nu equals to kt equal h nu by kt equals to x, we will get a proportionality constant of, we will get u proportional to t to the power uh, t to the power 3, because new is uh, this one, right? Nu is proportional to t, so nu square will become t square, and from d nu it will get another t, so t cube. So now after now differentiating it, cv is du by dt, right? So it will become t square proportional to t square. So in 2d, so we'll write in summary, in 2d, cv will be proportional to t square. In 1d, cv will be proportional to t, right? Now, and in this is all at low temperatures. Now at high temperatures, after calculating, we'll get cv is 3 nkb or 3r in 2d. In 3d, we'll get just nkb or just r. Okay.